Okay, now we're going to talk about datums, projections, and transformations. Okay, so this is actually a review of what have been, what we have talked about in geodesy. I hope you're familiar with this, or if you're not familiar, maybe this is where you're going to um, have a look at it, but I believe that you're familiar with it already. So this is just a refresher. So when we're talking about the datum, we're actually talking about an abstract coordinate system with a reference surface. So everything that we are measuring, everything that we are going to provide, they are basically referred to something that is called a datum. Okay, so when we're talking about horizontal datum, then we're actually talking about from where your coordinate is referred to. And also when we're talking about vertical datum, we are talking about where is your zero. That's basically what we are looking at. So for an international frame, I believe that you guys are used to having the WGS84 as your reference. Okay, so just an introduction that this is basically defined by the U.S. Department of Defense, and this is what this is basically for GPS, but we are used to having GPS, so that's basically how it is. So every single GNSS system, they have their own datum, but we can actually do the coordinate transformation or whatever, but we need to know what our specific datum is when we are doing the survey. So after we have the data, we need to project the data, okay, from geographic data into a map data. So as a refresher again, you know that geographic coordinates is defined in latitude and longitude. So you've got your graticular network. So you can imagine that actually in a map, they are actually defined as X and Y. So you've got your X and then you've got your Y in a flat surface. So when we're trying to make, when we're trying to flatten our earth, there must be a limitation. Okay, so whatever our projection is going to be, there must be a limitation of it. So again, basically what we're trying to do is to project the earth that is not a flat surface into a map. And the projection itself, there are lots and lots of types of projection. I don't think we're going to talk about that in here, but I think you're familiar with, for example, Mercator, you've got UTM, you've got transverse Mercator, and etc. And if you're familiar with it, then you will be familiar when we're working with, for example, GIS, because you need to define your coordinate system and sometimes your projection as well if you want to make a map or you want to provide the map to a client or something like that. And then I'd like to remind you about transformation, okay? So there are three types of transformation. The first type is the projected one. So you can do from projection A into projection B directly. So that's just basically two-dimensional transformation. So you will have either conformal, affine, or polynomial. It really depends on what your data looks like. And then you've got the geographic transformation. So you can either, if you've got two different datums. So for example, there's datum A and datum B, and you've got your data as a projection, the way you see it is basically from projection A, you need to transform it into your datum first, okay? Back to your datum, your geographical datum. Then you transform it into another type of datum. Okay, so for example, from WGS into something else. And then from that datum, you can reproject them either to the same projection or another type of projection. Okay, so if there's a change of datum, you cannot do this directly. Okay, so you need to transform them into your datum, back to your datum first, and then you transform it into the other datum and then back to the projection. The same if you've got a geocentric one. So you need to transform the projected into a geographic, and then from geographic into geocentric, and then you can change the geocentric datum from datum A to B, and then you will go back to your projection. Okay, so you need to know in what level are you actually doing your transformation?